And I'm wearing something which is called Testbed OS. So I lead a project called Testbed Operating System, which we have developed at Bristol. Joe is a lecturer here, and he was part of this project. He still is as a mentor. And Winston is our PhD student. So is Maria. And we also had Graham, who is also one of the PhD students as part of this project. And we also have another brilliant research associate called Lucy. She is not here today. So all of us, we are developing a testbed operating system for security and privacy testing at scale. This is the URL. Now I'll stop talking. I'll hand it over to Winston and Maria and let them do all the talking. Thank you.
So just to start with what the testbed is about, so basically it's a platform where you will find a bunch of tools and mechanisms where you can do a lot of stuff. So we are aiming to entertain a range of stakeholders, starting from the people like who are in the academics, researchers, regulators. So the idea is that we do have a lot of things in the testbed which would help you in doing a lot of stuff. Like let's suppose if you are a researcher and you have a codes with you and you want to make it public, and others want to replicate your study or want to test your findings and things like that, then you can, using the testbed, you can freeze your system and deploy it, and others can just simply grab that image and start using it, and they will reproduce your studies. So that's for the researchers and academics. For stakeholders like regulators, they aim to test different systems to see whether they are compliant, whether they are doing what they are claiming in terms of their facilities or systems. So we also entertain them in terms of as a third party independent testers. So they come bring in different vendors, and we then deploy those systems in our testbed and see and do different sort of testings and produce results, and pass on those findings or results to the regulators or authorities, and they can see whether the systems are actually compliant or not. So these are some of the things that we have done so far, and that's the broad idea of what the testbed is about. I'll hand over to Winston to give you a quick demo of what the testbed is going to do. Okay?
Thank you. Right.
No, I will bring this to the second.
Yeah.
Okay.
All right. Can everyone in the back hear me? Yeah.
Can everyone in the back hear us?
You need a microphone.
I do.
Yeah.
Yeah.
Microphone.
Yeah, it's running now.
Is this okay? Cool. All right. So I'm going to give you a little demo of the testbed. So to start with, I'm going to show you how you define your deployment. So if you're familiar with Docker Compose, this might be kind of familiar. So in this first demo I'm going to show you is an Android emulator. So here we can see I was using an Android with the 28 as the API level, no Play Store, so we can root it. I'll show you later why, and where in the network I will put it. We also have the network definition, so we're using software-defined networks. I'm going to place it on a switch, SW0, as you can see here. We have a router, and we have a public network to expose the emulator to the internet. So I have set this up previously because I needed to install Signal. So we can see here that same YAML file, but I'll go here and deploy it. So I just need to press up, and here we go. So let me just open Signal. So I have a message with a test account, so I will show you one of the privacy tools. First, I need to run Frida. Just start it. Cool. And then TLS interceptor. So I already have the command copied here. So Signal's called secure SMS internally. So essentially what TLS interceptor is going to do is capture all the messages coming from Signal before it gets sent and wrapped in TLS. So where is it? So I'm just going to send a quick message to pets. So that's sent. I'll just cancel that. So we can now see the output. So let's have a look at messages. So here we go. As you can see, is that? Yeah, it's a bit small. I think. Oh, I can. Sick. Yeah. So, yeah. I mean, there is some information here. We have looked at this previously. While this is in clear text, some of the stuff later on. If I just zoom out again. Sorry, it's jumping around a little bit. For example, here, we can't see what is going on here. Arthur, do you want to?
So just to add here, we previously used the TLS intercept in an experiment we did with Signal and 6 end-to-end encrypted messaging applications, and this was jointly done with University of Cambridge. And so the first version of the TLS intercept was from a student there called Tom, and then we have developed further on it. So we got the username and password that was being transmitted, that was captured using the TLS intercept, using which we could log into a delinked desktop. So that's in a paper that's published this year at Software Practice and Experience, which we published after due disclosure period, etc. Yeah.
Yeah. Okay, so that's one, and I'll just quickly show you the other one, timeline.log. Just a little bit more information about what happened in that time I ran the TLS interceptor and then cancelled it. Just general information. So that's that one. I'll turn this one off. You can see the emulator disappeared. I'll show you another one that is a bit more interesting in terms of there's more guest types. So actually, I'll just get VS Code open. If I go to pets, KVM compose YAML. So in this one, I've got a Docker container running Nginx, and I've got some HTML in there. I've got a Ubuntu virtual machine that I've pre-prepared, so when it gets loaded into the test bed, it creates a link clone, so we don't actually make any change on the original image, so you can make loads of clones if you'd like. And again, another Android emulator like before. And the network is basically the same. So, pets, yeah. Run command, if I just bring this one up. So we'll see the emulator. It's already there. Here we go. So virtual machine is starting. Let me just log in. And just to kind of show you, you can see up here, 26 seconds ago, the Docker container started. So if I bring up the virtual machine, so I said that there was some HTML in the new session. There was some HTML on one of the Docker containers. It was on 10.0.0.10. As you can see, I can access that. So that's the internal network. And the same on the Android emulator. Apologies, it's a bit small. Maybe I can zoom in. That's the most I can do. Basically, it says the same bit of HTML. So yeah, that's a little kind of demo of the test bed. Let me turn that back on. I'll show you the resource monitoring. So you also capture kind of resources of the host and the guests. And also you can put together as many servers or laptops together as you want to kind of have like a distributed test bed. So that's something else we've worked on. So you can have like really large scale deployments. So yeah, I think that's all.
So the demo of the testbed is now over. So 2 quick points. One, we found on Signal that it's easy to do simple cloning attacks on Signal. That's was what we reported in the paper. So if, say, in cases of intimate partner balance, border officials, or, for example, in case of managed machines, it's easy to compromise Signal desktop clients, WhatsApp and Telegram, Viber, we can, and Element, we could not. And in terms of the testbed, the idea is to have diverse guests on a host, quickly deploy them, deploy applications in them, run them, test them, capture packets or use the probes in similar to Docker exec commands, and then publish those results or use those results. And then we also have a linked clone and snapshotting feature. You can snapshot VMs and give upload as artifacts, or you can define one YAML, make 24 or 14 clones of it. We recently used the testbed OS in a capture the flag that was used at Bristol. We had 56 VMs. Okay, thank you. Now I'm going to hand over to you for the other parts of the session.